This lesson is on classification of elements. Periodic table was originally arranged by Dmitri Mendeleev in 1871, and he took all of the currently known elements and put them in order by increasing atomic mass vertically, up and down, and their physical properties horizontally, left to right. Physical and chemical properties for an element are determined by the electrons that an element has. Those electrons are going to behave differently between different elements. And the arrangement of the elements on the periodic table depends on these properties, their physical and chemical properties. So they're going to be similar in their groups. So the elements now are arranged by atomic number going horizontally and physical properties vertically. So your up and down groups are going to have similar physical and chemical properties. They're going to behave similarly. We can put the elements into categories based on their electron configuration. So how many electrons are present in a certain sublevel or orbital at a particular place. The representative elements are the elements in where your outermost S or P sublevel is partially filled. Representative elements are also called your group A elements. So you'll see them typically noted with the Roman numeral A. So group Roman numeral 1A, Roman numeral 2A, 3A, 4A, 5A. Those are all your representative elements. The group number is going to equal how many valence electrons it has. So valence, how many electrons are on the outside, outermost shell. 4 of the groups within the representative elements have very specific names. Group 1A are your alkali metals. That's your lithium, sodium, potassium, rubidium, cesium, francium. Group 2A are your alkaline earth metals, beryllium, magnesium, calcium, strontium, barium, and radium. Group 7A are specifically called halogens, fluorine, chlorine, bromine, iodine, and astatine. And group 8A are your noble gases, helium, neon, argon, krypton, xenon, and radon. So these are the representative elements. You have your group 1A and 2A highlighted over there to the left, and 3, 4, 5, 6, 7, and 8 are highlighted to the right. Your noble gases have their outermost S and P sublevels filled. They have different group names. The newest numbering system just numbers the groups straight across 1 through 18, or it could be 0, which is an older numbering system. And a previous numbering system uses Roman numerals. So the A's are going to be 1 through 8. The B's would be the newer system 3 through 12. Noble gases are sometimes called inert gases because they're not going to participate in reactions. They're just going to hang out by themselves. You would have to force them to react with something else. And this highlighted group here all the way to the right are your noble gases. They do fall under the representative elements. Transition metals. They are where your outermost S and D sublevels have electrons. Transition metals are also called group B. So the representative elements are A, the transition metals are group B. They are characterized by the addition of electrons to the d orbital. So when you start getting to the transition metals, that's when you start seeing d orbitals start to fill up. And they're this middle block here. Okay, so you'll see the representative elements are not highlighted on the left and the right. It's this middle part that drops down a little bit lower that are your transition metals. Your intertransition metals, they are where the S and F sublevels contain electrons. And we will not be doing electron configurations for intertransition metals, but you do need to know that they would fill the F sublevel. So they're characterized by addition of electrons to the F sublevel. And they're the 2 lower series down here, the lanthanide and actinide series. They're the inner transition because they would fit into the last two portions of the transition metal group, but that would kind of throw the periodic table off, so they pull them out and down to the bottom.